Hello, everyone. Thank you for coming. My name is Violet Sia from APJ Marketing at Enterprise DB. I will be your host today for this webinar. We are joined by Jamie Watt, VP of Global Support Services, and Ajay Patel, Crowd Services Delivery Manager from Enterprise DB. Before we get started, I just want to go through a few housekeeping items. This presentation is being recorded and we will be sharing the recording along with the slides after the broadcast. The lines are currently muted. If you have a question, please feel free to submit it in the question panel. We expect today's session to last for about an hour, with the presentation lasting approximately 45 minutes, but we will have some time for Q&A. If we do not have the time to address all questions, we will follow up afterwards with anyone whose question was not answered. So without further ado, I am handing over to Jamie and Ajay. Jamie and Ajay, over to you.
Thank you, Violet. Good morning and afternoon, everyone. As Violet had mentioned, both myself, Jamie Watt, and Ajay Patel will be, I suppose, treating you guys to an experience to really illustrate to everyone how quick and easy Oracle migration to Postgres in the cloud when powered by EDB can actually be. So, a quick overview of what we plan to go over today. We will give an introduction briefly of who is EDB, what is our presence in the marketplace, who do we stand as from a luminary perspective, and really what our context is overall to the Postgres movement itself. Additionally, we'll be going over migration steps, which helps to illustrate how we get from Oracle to Postgres. Will allow to a better insight on picking the right migration candidates, so that way you can identify, what of your existing databases, your existing schema would make easy candidates, what make moderate candidates, and what may be difficult candidates to really get over that migration hump. We'll also be giving you a preview of the Postgres in the Cloud solution that EDB offers called the Cloud Database Service. Finally, we'll be going through a demo of all of these together. And lastly, we'll have a Q&A. So without further ado, EDB has a worldwide presence and has been in the Postgres game for over 14 years, 15 years at this point. We span most of the continents on the globe, obviously with some exceptions. We haven't yet put an office up in Antarctica. However, we do have heavy presence in both North America as well as Europe and Asia. We are the world leader in the open source based model of Postgres, as well as the services attributes that are often tied to whether it be open source at large or the ever increasing complexity associated to these types of DevOps solutions as they transform you from what used to be the four walls vendor type solution into a hegemony of various vendors. And doing so successfully for our candidates and our customers each and every day. We are a proven factor, recognized as an RDBMS leader by Gartner and Forrester. From 2013 to 2018, we are members of the Magic Quadrant. We have been committed, as I mentioned, founded since 2004, and we are the largest contributor to the Postgres base. We represent 40% of the core team, and during the last code analysis, we had actually contributed to or solely authored 25% of the existing code base. We have a global customer base of over 4,000 with 300 employees spanning the many continents that I had mentioned prior, with offices in 16 countries. Some of our largest customers and reference customers you can see below, from US Army to KT to Ericsson, and onward to ABN AMRO and Rabobank. So as I had mentioned briefly before, with over 4,000 customers, we enable people each and every day to work smarter, reduce their overall risk to their IT infrastructure, as well as the change that they're introducing, which can often bring all sorts of elements and factors of additional requirements on an environment, and how to make them more productive with EDB. Postgres is certainly an extremely competent RDBMS, and as of 2019, of course. And with EDB's knowledge as well as the capabilities that we provide via both our toolset and advanced server, we help customers of all sizes reach the level of excellence and overall efficiency that they're hoping to sustain or achieve. US customers, we have a wide swath of them, and from all industries, going anywhere from AT&T to the Gap to HP to Aon and Sony. Within Europe, some of our larger customers include the London Stock Exchange, Volvo, ABN AMRO, Ericsson, Telefonica, and others. And within APAC, we have no shortage of customers there as well. Some of the largest presences include Hyundai, Alibaba, DBS, and Samsung. Now, if you look at the entirety of our customer base, we have 102 of the Fortune 500 and 337 of the Forbes Global 2000. So clearly we are experienced not just with enterprise, not just with all sizes of customers, but also those that comprise some of the most recognized brands in the world. Now, as I had mentioned, we do represent a significant portion of the committer and core team contingent. On the core team itself, we have both Bruce Ramjan, and Bruce Ramjan was one of the, considered to be one of the godfathers or founders of the overall Postgres movement, and Dave Page as well. Some of you may recognize Dave as well from his work, not only with our products, such as Postgres Enterprise Manager or Enterprise Failover Manager, but also PG Admin. We have a number of major contributors, including Andreas Frund, Devram Gundas, Robert Haas, Thomas Monroe, Amit Kapila, and more. And of course, we have a even further and larger number of people who are continual contributors to either the core itself or some of the surrounding tools or solutions or extensions. Those include Amul Sul, Ashish Vashi, Jivan Ladi, Mithun C, and Rushab Bhatia. So we wanted to take a moment and ask you guys a question before we jump into the actual content and the core demo of today's overall efforts. Given that the focus of today is, of course, migration and how it relates to the cloud, we wanted to pose a question to everyone. How are you planning to migrate? Are you in an Oracle on-prem solution today and aiming towards a Postgres solution in the cloud? Are you in an Oracle on-prem solution today or in a colo and looking to migrate over to Postgres equally on-prem, colo, or otherwise? Or have you not really necessarily made a plan as of yet or finalized it? And Violet, I believe we were going to pose that as a survey question as well, or a poll question?
Yes, I am launching it.
Okay.
Yeah, why is it?
So while people are getting a chance to go through the poll, we'll start to jump in a bit into the content or the meat of it. And you should be able to see the poll, which is now opened. And we'd love to hear your feedback or your story of where you are in your cloud journey and your Postgres journey today. So when we take a look at the journey from Oracle to Postgres, our focus is on ensuring that we're able to get your Oracle workloads to the cloud in its entirety. So if you look at some of the larger presence folks today in the global Postgres world, you of course have AWS, and they get you part of the way. They will handle your schema, they'll handle your data. Now, we go one step and then all the steps further depending upon the solution that someone chooses to elect. Now we can get you, one second, sorry. We can get you most of the way, reflective of your schema, your data, and your code, or all of the way, schema, data, code, and interface. Now, if you're looking to go strictly into your own privatized solution, you may elect for that middle path where you've got your schema, data, and code using advanced server and deploying successfully and stably from your prior Oracle environment, or perhaps it's actually running in parallel and you're just trying to reduce your Oracle footprint. If you're looking to go all of the way and you actually want a full-fledged cloud interface, we of course offer that as well. So our database compatibility, as it exists for Oracle, is extremely pervasive. We've got a bit of an eye chart here that goes through the majority of what we offer in terms of compatibility, but the heavy hitters tend to be where we see the PL SQL compatibility, blobs, clobs, our drivers, of course, where you're looking at OCI and Pro-C compatible drivers, and of course, our ability to support things such as an ORM application, such as Spring or Hibernate. Now, of course, we do have a bevy of other capabilities that help you make that journey into Postgres that much easier, where if you're going into community, you would not necessarily have these capabilities. If you look at, let's say, some of the user-defined exceptions as an example, if we're looking at decode, NVL, substrate, MVL2, DDL syntax support, and of course, when you get into an even more granular level, but even more important in some cases, things like stored procedures, which is really kind of the meat and potatoes, so to speak, of what people are looking for when they want to make a transition easy on their development, overall development strata. Now, one of the things that we introduced, which is not necessarily relative just to Oracle compatibility in Advanced Server 11, was the function of Pragma autonomous transactions, as well as DBMS redact. As we get further into a world that is focused heavily on things such as PII, PCI compliance, where you're looking at GDPR relative to Europe, and certainly for those of us who have global interfaces needing to comply with that regardless, this capability helps to drive that overall power into Postgres where it had not existed prior. So if we look at the drivers themselves and what we offer to enable our users, you can clearly see that we do allow for our own releases of the JDBC driver, the ODBC driver, a .NET driver, and OCI. Now, alongside those, there is full PL SQL support. And we'll get into a little bit more about the PL SQL side of things, or at least the syntactical side of things shortly, but also ref cursor and Oracle type specifically. Of course, user-defined exceptions, as I had mentioned prior, name parameters, data types, struct, upper column names, and in-out parameters. So when you take a look at what of your existing workload is actually going to be accommodated by an easy migration, there was actually a study that was done by TechValidate where they looked across the efforts that had been exerted by our customers and others in that journey. And they found that 50%, and actually greater than 50% of migrations, are actually considered to be relatively easy. 30% involve more work, and 20% find themselves to be rather difficult cases where you really need to justify whether or not this is a larger initiative to go to Postgres, or if there are other changes coming in the application or within the infra itself, which lead you to take that journey regardless of the level of difficulty. So let's get a little bit more into what makes a good candidate and perhaps a not so good candidate. So where we look at good candidates, as I mentioned, those that make use of ORM, be it Hibernate, Spring, or similar examples, those certainly make good candidates. Those that initiate their connections via JDBC, anything that is really using stored procedures that are written in PL SQL versus being written in either Java or PLC, where you see a number of concurrent active connections that really don't exceed, let's say 1,000 active actual connections to the database. Again, you do have to kind of weight that and understand what use you're making of things like DRCP or other versions of Oracle connection pooling to really understand what your true connection count is. But that kind of gives you a rule of thumb, so to speak. Where you're looking at a database size of 5 terabytes or less, it certainly makes a very easy argument. And of course, application source code and application developers, where they're available to be part of the journey, it certainly makes things most smooth, given that if there's any refactoring that needs to be done or that could be done to improve, let's say, performance issues during the transition, then these are great candidates. From a infra perspective, if you're not really making use of, let's say, rack from a scalability perspective, and you're not relying on things like flashback for temporary drops or any other sort of restorative event based off of, let's say, recycling bin needs, so to speak, these are all really good examples of what we would see as a smooth candidate that requires little effort. Now, what are more difficult targets? So those that require use of the OCI interface, as mentioned before, we do support that. It does depend on how stringent your syntax is and how well it complies, whether or not you're really looking at, let's say, an ANSI spec use of syntax versus some of the looser code that is still supported by Oracle's overall syntax. If you're looking at spatial data or XML, it's a judicious practice of determining how large and how pervasive that use is. And then extensions where you're using .NET and ODBC. Again, as I mentioned, we do provide our own extensions or our own drivers for those, and they certainly work well for many customers who make use of those within the EDB family. But those are moderate candidates because they may require some change. They may need some refactoring from a code perspective and just an overall stronger eye to them. That's, of course, where EDB tends to shine, whether it be purely from the product or where you're doing a joining effort, perhaps with a professional services engagement, to really make sure that the architecture is sound going into the overall new deployment. Now, what's typically a more difficult candidate? As I mentioned or alluded to a minute ago with ANSI compatibility or ANSI stringency, Pro-C interface needs certainly require a bit more of a restrictive eye to what is being done and what is being moved, as Pro-C has a much wider level of support for a stretch of syntax that may not necessarily be 100% compliant with what the SQL standards are, but it still allows it to execute. From our side, we tend to adhere almost strictly to, in most cases, what the SQL standard would be. But as long as that's the coding practice followed on the development side, then certainly, regardless of the fact that it may present difficulty to some, you would be effectively in the clear from that perspective. Now, if you're looking for transaction management within inside your PL SQL, as an example, if you're looking at rollbacks or save points or exceptions or commits within the PL SQL itself, that's again a more complex use case that requires some overall estimation of the gains you'll make. Stored procedures that are written in Java may or may not work with what we actually have out of the box as stored procedure compatibility. And if you're looking at a infrastructure that requires rack capabilities and a transaction flexibility or restorative capability that requires flashback, again, that's a much more difficult candidate to consider, and you need to evaluate whether or not, A, that's the practice you want to persist with, and B, whether or not that can be maintained in any sort of custom deployment once you get into the Postgres environment. And of course, finally, if you're looking at other Oracle proprietary extensions, then that's where things certainly become an argument to determine whether or not it's the right move. But again, we've seen a number of customers who have gone from either rack-intensive solutions or, as an example, Golden Gate. But it does require a keener eye taken to the overall architecture to determine whether or not you need to make broader changes to the infrastructure to support your journey into a much larger and much more flexible open source space. So, with the migration portal provided by us, it's really your fastest way off of Oracle to the cloud. We offer native Oracle compatibility that does actually handle schemas, database code, and application interfaces themselves. This is pulling from a exceptionally extensive knowledge base involving 10 years plus of migrations experience built into what we see as our use cases and our ability to convert. And it is continually crowdsourced, anonymized, but crowdsourced to discover new ways to handle code translations. As of today, we're a little past a year into the life of the migration portal, We've got just under 1,800 users, about 5,200 Oracle schema assessed, and a whopping 2,969,671 DDLs assessed at this point. And that is continuing to grow on a daily basis. So as you can imagine, this certainly leads to a robust and ever-improving engine to allow you a simple and easy migration path forward with your schema. So adjoining that, as mentioned before, we've got our Cloud Database Service, also known as CDS, which is hosted on the public cloud. We do provide this both in an on-demand state as well as reserved. So for those who are looking for perhaps cost savings or a long-term commitment, we absolutely encourage them to go through, obviously, a trial period, perhaps use it in an on-demand state to make sure that you really feel that you're getting your bang for your buck. I can assure you it is certainly overall competitive, both for the value, the capability, and of course the price, and it beats all effectively globally where we're looking at the ability to support the actual Postgres needs. And then moving into a reserve state where you're looking at a 1-year or perhaps a 3-year commitment to really optimize the savings and the journey that you're going through, as well as align to a solution of more permanence. Now, as mentioned, the access is easy. Provisioning is simple. You guys will see that in just a few minutes. And there are several use cases that are based on predefined templates or have led to our predefined templates where you're looking at whether it be developer needs of various sizes or production needs of various sizes. We have set up predefined templates that allow you to launch a cluster with a footprint that is most aligned to those needs. Now, as mentioned, we fully support the Oracle compatibility features that exist in Advanced Server in CDS. We also allow for PostgreSQL instantiation as well, all of which is handled via our overall provisioning engine, which allows for high availability, ease of use, backups, and redundancy, and of course, replication to streaming partners. As part of that, there is load balancing for read-write operations. As I mentioned, we do handle automatic failovers, and we will handle scale-out as well. Ajay will touch on that a little bit more because we handle scale-out in a couple of different fashions where you're looking at both the load placed on the system from a connections perspective, but also where you're looking at your needs for let's say, expanding just based off of size constraints. This does handle secure data encryption. We both handle encryption at rest. We make use of the OS encryption that is available within the images themselves, as well as ensuring that the connections that are established to the database are secure. And as mentioned, it is true Postgres. We are aiming at allowing people to have the same Postgres anywhere. Now, where they're making use of the needs to migrate off of Oracle, Advanced Server is absolutely the best use case for them, but offers a significant majority of the overall Postgres competency and adds to it the ability to have Oracle capability built within as an extensible environment to allow you to, again, either create a larger hegemony or to reduce your footprint if you're looking to migrate out of your prior vendor. And we do offer complete management of those databases. So, as you can imagine, that's certainly a powerful solution. It is available across a number of regions today, which again we'll see shortly. And we have a ever-growing number of different types of instances. So based off of your workload needs, we certainly are scaling downward and upward towards each profile as they become clearer and clearer within our customer base. So we do have a fully featured trial. Currently, it is a 7-day period for each cluster. And the actual access to the trial service itself is perpetual. There are limitations when you look at the size of instances we allow for. And of course, there are some constraints operationally around things such as IOPS and other behaviors. But it is fully featured. So if you're looking to effectively dip your foot in the water and give it a shot, it is accessible 24/7, 365. And we'll give you a sense of what the service is. And adjoining that, as you'll see shortly, we make our pricing and the accessibility to get up and running into a complete paid environment easy. So, as mentioned, we're now going to move into a demo, which is going to show you not only the power of the migration portal itself, but also the cloud database service. Ajay, I'll hand it over to you.
Thanks, Amy. And hopefully everybody can see my screen. All right, so guys, as a part of this demo, I'm gonna show you that how simple it is to spin up any cluster, whether it's Postgres or ADB Postgres on cloud, and how it is to manage it. So the first thing is how to log into CDS or cloud database services. So you can go to Enterprise DB website, go to cloud option, and click on cloud database services, or just type in cds.enterprisedb.com, and it will take you to the landing page. And once you reach there, and if you're an existing EDP customer or had already been registered to enterprisedb.com, it becomes much more simple because you just have to log in and get started. However, if you're a new user and you're not, you don't have any existing relationship with Enterprise DB, it's a very simple format to create an account. You just have to provide a couple of information in terms of your name, last name, email ID, phone number, organization, country, and you're all set. For the sake of this demo, what I'm going to do is I'm just going to log in as my pre-created email ID. And this will take me to the data to CDS portal, and there we will see that what kind of different options we have, what kind of features we have, what kind of regions we support at this point of time. All right, so this is how the CDS portal looks like. As you can see in the screen, if you're a first-time user, you might not be able to see all those console available or this homepage. As all the new users will have access to the free trial, which, as Devi mentioned over the previous slides, that you'll be able to spin up cluster for 7 days to a very specific size and a limit to a number of nodes. However, I have provided my credit card information, and I can spin up a larger size instances which can be sustainable for a longer duration. So what I'm going to do is I just go. You can see that right now we provide support to 6 different regions, which includes US, Europe, and Asia Pacific specifically. But having said that, if you want uh, to run your instance or workload to a specific region which is not part of it right now, what you have to do is just send an email to cdshelp@enterprisedb.com, and we will make it available to you. It's all about making this available uh, to our software and provide as a part of portal. So next thing is, let's go and dive into how the portal looks like, what kind of feature it has. So right now I'm logging to US East console, and again, once you log in, you don't really have to uh, do a lot of stuff. It's very intuitive, plain and simple. And as you can see, there are already a couple of clusters running, which I'm going to use as a part of demo to demonstrate different feature and functionality of cloud database services. So first thing we are going to do is to create a cluster. And a cluster is nothing but a simple plain database. It could be Postgres or EDB Postgres database. So there are 2 different options. One is you can manually create a cluster or use a template. So I'm going to run it by one just to show you different options, and then we are going to actually create a cluster just in few clicks and few minutes. So if you decide to choose or create a cluster manually, what you have to do is just provide your cluster name, select the DB engine version, nothing but the Postgres or EDB Postgres version you want to create. Right now we support Postgres 10.11. Then you select your server class. You want a small size machine, a large size machine. Basically, it talks about the vCPUs and memory. Number of nodes is nothing but read replicas or high availability, how many streaming replication you want like to set up, the storage requirement, encryption, as JB mentioned on the previous slide, that we do have an option to encrypt the database. Uh, and again, if you want, and again, this is specifically for where you want a very specific IOPS requirement for your workload. So you can check this, select the IOPS you would like to do, user ID, password.
Our apologies, folks. It appears as though we ran into some audio difficulties. Violet, are you able to hear us again?
Couple of minutes ago, it was silent just now.
Okay. Yeah, it looks like we dropped audio right around step one, so we're going to kick back off right from step one and move forward.
Sure. So I'm gonna just probably cancel it, go to the new cluster creation option. As I mentioned that like we have two options available. One is manual defining cluster, which gives you more option to fill the form. And the second option is launch from template, which is again we have, this is availability and based upon the use cases we have seen across the industry. And I'm gonna cover it as a part of my next step. So let's go just see different option available as a part of manual cluster creation. You just have to provide uh, the cluster name, choose the DB engine version. Right now we support two versions of Postgres and EDB Postgres, which is 10 and 11 on CentOS 7. If you have a very specific requirement about your server class, and again in terms of the CPUs and memory, choose the type, and number of nodes is nothing but basically the HA or the read replicas you would like to have. So let's say I'm going to select three, which means one master and two slaves as a part of the cluster. Storage, let's say 100 GB, encryption, ABS optimized, and ABS optimized nothing but if you have a specific IOPS requirement for your database performance, make sure that you select it so that you get a consistent performance for your the volume or the data types, I would say. The user ID, master username, password, and the next option is so next option, as I have selected an option of three nodes, which means merge master and two slaves. So one thing I can do is either I can select a availability zone which are available depending upon the region. If I don't do it, CDS basically uses algorithm, and it makes sure that your master and all the replicas are available across different AZs. So one of the use cases is just in case one of the AZ goes down completely, you will still have your data available across different AZs. Uh, so so you can select it. I'm not gonna do it right anything right now. Next option is basically IP whitelisting. Putting probably your IP address of application so that can make connection to database. And the next option is related to backups. So another important feature where you can automate your backups and you can retain your backups for a longer period of duration. So you just have to provide the retention, the window, and archiving if you want to enable point in time recovery for your database clusters. So what I'm going to do is I'm going to cancel this and go to cluster again and launch from templates. Uh, so again, as we mentioned that there are a couple of options available depending upon the use cases. So let's say if I go to the option production uh, department Postgres advanced server, so it basically creates a cluster with a very specific configuration. So what you can do is you just can go check what kind of configuration it has as a part of template details, and you can see that it's a M5 X4 X large machine with 4 CPU, 16 RAM, the storage of 200 GB, and all those options which we have seen as a part of manual cluster creation, you will be able to see here. So I'm just going to cancel it, provide a cluster name, let's say test. Okay. The user ID password, I'm just going to go with default. I'll just put cider, and again, you can see a port 9999 because we use a load balancer, a PG pool by default for read scalability. So again, a very interesting feature. So if you have multiple read replicas, you can use load balancing or read load balancing feature to achieve more or a high read scalability. So next thing is everything is all set. What gonna do is I'm just gonna head to launch cluster, and that's pretty much it. As you can see that within few clicks, I was able to basically launch a cluster. It's gonna take few minutes to do initialization and bring up the cluster and high availability ready for you. Meanwhile, I'm gonna cover rest of the features in terms of uh, scaling up. So next option is scaling up, which is nothing but either adding high availability to your master or creating read replicas uh, to or adding a read replica to your cluster basically. So you can select up to 5 number of read replicas, and what it's gonna do is it's gonna give you an option of different AZs. And again, as I mentioned, if you provide the AZ which is okay. Otherwise, based upon algorithm, we make sure that all the read replicas are created across different AZs to handle any kind of AZ catastrophe. Uh, so that's one option. Next option is scaling down. Again, if you want to just reduce your read replica, you can certainly do that. It's pretty easy to do. For example, for this specific cluster, which is named as failure, you can see that there are two replicas, and if I want to remove one, I just have to select any of them and just click go next, get a confirmation, and I'm all set. So again, few clicks, very intuitive, very simple to create a scale, add a read replica or remove a read replica. Uh, so next option is backup. As I mentioned earlier, that either we can have an automated backup which is created by CDS for all the clusters. Otherwise, you can take a manual snapshot. And one of the use case is think about a situation when you want to retain a backup for a longer duration, probably a year, 6 months, or every quarter. So it becomes very easy using this. What you have to do is just click on the backup, give a tag name. I'm going to put it as retention, uh, my cluster name, and August 2019, and just hit on the backup. So what it's going to do is, as it's a manual backup, it's going to retain it as long as I want to, until as I, and there is no retention policy is going to touch this specific backup which I just performed. Uh, Similarly, uh, The next option is cloning. Cloning is nothing but basically, creating another similar kind of set for your database. And it's very simple to do. For example, you have a production running, and one of your developers suddenly asks that, I want to do some kind of testing on UATM development. It's very simple. You just have to select your cluster, clone it, and again, we give you two options. One is either you can clone it through template or manually clone a cluster, decide the availability zones, subnet, the server class. Again, not necessarily the server type has to be the same as the source one. You can either increase or decrease depending upon your requirement. So that's one option. One of the key feature what CDS provide is an upgrade, and I'm talking about not and just upgrade of OS and DB minus version. Okay, so for example, if there is a critical security patch which you want to apply, either it's Postgres, ED Postgres, or on a OS level, you will be able to see that information somewhere next to your cluster. So if you see the symbol, which means there is a security patch or important update is available, and you can apply that using this option. But the most important feature is the major version upgrade. So for example, this is an EDB Postgres 10 which is currently running. So I can easily upgrade to either uh, depending upon the version which I use, I can go to version 11 right now, and it's still simple to upgrade. Again, this is an offline method to upgrade, but it's very fast, and it's very easy to upgrade. So next one is scaling machine type. And scaling machine type basically is if you feel that your existing machine is not able to handle a load, or probably you want to or do you have a development machine for testing, and then you realize that it is time to move it for production, and it was a very small size, you decide that my production machine should be R5 4x large. So you can upgrade the machine, or and again, this is an option. You can similarly, if you decide that your application is going to hit by a lot of lot of users, and it's going to suddenly increase the load for a specific a specific day, or a sale. Let's say, for example, if you're running e-commerce, what you have to do is you can scale up your machine to a larger size. And next one is restart reloading a database. So this personally, I really like this feature because I'm gonna tell you a major differentiation, which basically differentiate key features in terms of what we provide in cloud database services compared to other cloud services providers. So, uh, you know, we give you a true super user admin access, which means you can actually run your alter system command on a database, which you will not be able to do with other cloud service providers. Again, this is a very important feature where you will have access to all the functions, uh, the system functions, the alter command, and you will be able to do the same operation what you can do on the Postgres or EDB Postgres version of on-premises version. It's the same Postgres everywhere. That's what we believe as a company, and that's what we provide as a part of the cloud. Uh, Again, so next feature is administrator setting, and basically to IP whitelist or open a port or IP address for your cluster and deletion of it. What I'm gonna do is to just probably talk about now, or probably demonstrate that how what are the key differentiator or key features what CDS provides. So let's take an example of, let's go to details tab, where we can see that uh, it has information about your cluster, the basic information. I'm not going to cover that in detail, but as a part of failure mechanism or high availability solution, what we do is we provide two mechanism of failure. One is either you can choose to fail over to your existing read replica. So for example, you have one master, one slave, or so the failure happens to something goes wrong with your master, the replica becomes the new master. The second option is that we don't touch the replica, we spin up the new master and then do the failover. So Again, the choice is completely to a user, how a user want to do a perform a failover for that. So what I'm going to do is I'm going to meanwhile demonstrate that how the failover or the CDS handles the failover mechanism. As you can see, I have a one master and two slaves running for this failover system. And from the backend, I'm just going to simulate how the failover happens. So I just terminated the master. It's going to take a few seconds to identify, and and once the master is gone, it's going to initiate the failover. Meanwhile, let me cover the other auto scaling option where, as we mentioned, we do auto scaling not just as a part of storage. And again, this is one of the key differentiate what we have CDS is there is the storage limit is really high. So we can easily provide a database storage up to 350 terabytes, because again, one of the biggest challenge with the other cloud service provider, where there is a data storage or the volume storage limit is pretty less. And second option is uh, read scalability. Basically, what happens is if there is a uncertain load on your system or your cluster and you want to use this option, what it is going to do is it's going to create additional read replica based upon the number of connection which hits your cluster, and it's going to auto scale automatically. So you don't really have to worry about adding a read replica, or probably creating or uh, thinking about a workload, how it's going to handle it. So I'm just going to simulate that to see for scale up cluster. So right now it does not have any replica at this point, any replica. But what it's gonna do is, as the threshold is set to very low, and I have just used a simple script to increase the number of connection gradually over a period of time for this particular cluster. So after a few minutes, you're gonna see that it will add one more cluster, and it's gonna use that cluster for read replica, or probably read load balancing.
Now, while we're waiting on demonstrating both of those features, um, do we have a time to possibly demonstrate the migration piece itself?
I think, yeah, it's gonna just take a few minutes. I
Okay.
can necessarily do that. Yep. So, uh, so as you can see that it's very simple. You can that see that it's adding one read replica, and this is a failover where now we cannot see a master, but we see only replicas, and this is gonna be the new master after the failover happens. So we demonstrated both the features, where we discussed about, we basically showed the scale up that for read scalability, and the failover mechanism, how CDS handle the failover for database clusters. So let me show you very quickly. It's going to take probably 5 minutes to show how migration portal, you can actually migrate your Oracle schema from your on-premises or any cloud source directly to CDS. So again, what we believe in, that any migration happens in three steps: schema assessment, schema migration, and database migration. As a part of this demo, I'm not gonna basically do the actual data migration, but I'm gonna cover two steps. First two steps, which is schema assessment and schema migration to directly to cloud, and especially to CDS. So uh, you can go to enterprisedb.com and log into migration portal, and once you do that, you'll be able to see something like this. It's a very simple basic console. It's available for free. That is the best part. What you have to do is create a project. Let's name it uh, Oracle migration. Okay. And what you have to do is you select your source, the version, uh, the target database. I'm going to select EPAS 11 for it, because it's going to generate the details depending upon this version. However, the most important thing is how to get the source or the DDL file. Okay, so it's very simple. We use or provide a utility, a SQL based utility, which basically extract schemas or the DDL definitions from your Oracle source, and put it as a SQL file. Again, I'm not going to show you for the sake of demo, because we don't have much time. So what I'm going to do is, I already have a pre-extracted schema available, and I'm just going to upload it, and just run assessment and let's see what happens. So it's going to take few seconds or few minutes depending upon how many objects you have. But as you can see that the compatibility was 97%, which means the HRS schema of Oracle 12c is basically 97% for the compatibility for EDB Postgres. So what I'm going to do is just go to the details and see what we have done basically as a part of this assessment, right? So there is one field object 21 repaired, which means EDB migration portal has repaired 21 objects for you, right? Without any effort. 15 has been passed directly, but one has been failed. So what I'm going to do is just go to the details tab and see what has failed. For error example, which we have induced specifically for the demonstration perspective, that you see that this SQL basically could not convert it into EDB Postgres. So the best part of migration portal is that it gives you some kind of hint or solution so that you can go and apply real time, which I'm going to do. So for this partition, it suggested I'd use double quotes for the partition, and I'm going to run the reassessment and let's see what happens. Okay, so reassessment has been done. The success rate, let's see the success rate. Now it's 100% compatible. As you can see that it was very easy and quick. After that, there are two options. One is either you can download this as a SQL file, run it somewhere on your on-prem for testing, or else the second option is you can directly move the schema to cloud database. Okay, and one of the requirement is you have to make sure that the cloud database is pre-created. So what I'm going to do is I'm just going to choose one of the databases. Okay, and let's see this one. Okay, might have to add it one more time. And I'm just trying to show you that that the schema does not exist, but as soon as we move the schema, you will be able to see that in the cluster. Okay, I might have to. Seems like I used the wrong IP address. Okay. All right. So right now we just do two databases. One is EDB, one is Postgres. So what I'm gonna do is I'll go back to migration portal, provide my IP address of the database, the port, database name, user, password, test connection, and I'm just going to deploy the schema directly to the cloud database. It's going to take a couple of minutes and it's done.
And while it's doing that, can we look at the failover and the scaling activity?
Yep, sure. And so you can see the failover which we did. So we had one master, two slaves. When the failure happened, we completely destroyed the master, and the failover initiated the replica become the new master. And as you can see that, when we created this cluster, we have 3 node cluster, which means one master and two slaves. So automatically CDS has added one more read replica to make the cluster complete. So as you can see now, we have 3 clusters working. Again, you can go to the event tabs and see the whole operation, what happened exactly, when the failover started, what happened actually on the back end of this. Similarly, for cluster scale up, now we can see that it's had created, basically taken a snapshot. It's basically creating a new replica, and now you can see there is a new read replica which is available as a part of this scale up operation what we did. Let's go back to our cluster refreshes. And as you can see, if you remember the project name, what we created, it says Oracle Migration. Now it's being created as a database. And if you see the schema, you'll be able to see the HR schema and all the tables, what we have seen as a part of the schema assessment, basically. So
Great.
So, the key take or the key features I would say from this demo is that, the simplicity of creating a cluster and managing it, the automatic failover, just and scalability or auto scaling, just not from the volume perspective, but also from read high load or read situations, and creating HA, of course. So that's pretty much it.
Okay.
Up to you, Jamie.
All right. Can you transfer control back to me, please?
Sure. All right. All set.
Thank you, sir. Okay, so hopefully everyone can see my screen.
Yep.
Okay, great. So as Ajay mentioned, the big pieces that are really the takeaway from this is the Oracle compatibility, the high availability, the failover capabilities that exist both within the cluster itself, as well as cloning capabilities for where you look to replace the master versus electing a standby as a new master. All of this is available in Cloud Database Service as it exists today across all regions. You've seen a pretty clear link between the Cloud Database Service and the migration portal and the simplicity. Despite some of the technical difficulties we ran into over the course of the webinar itself, the actual process is very straightforward and very transparent in terms of all pieces of the process. Now, one piece that we haven't touched on yet, and we're just going to touch on real briefly in the interest of time, is backing all of this is the same enterprise level support that has been driven as a global capability and global winning leader in terms of the competency and the execution from the support team within EDB Postgres. We deliver not only live support, whether it be via email or portal or phone, but we also deliver it via more passive methods, depending upon how you elect to get your answers. PostgresRocks.com is the community that is run by Enterprise DB, available to all and accessible by all. But within there, we have a growing number of Knowledge Cloud articles that are specific to CDS use cases, as well as migration portal articles, allowing people to understand not just the process, but tips and tricks. Additionally, where we have blog content growing, we are continually adding to blogs as well to illustrate larger purposes, where you may want to migrate not just from the migration portal, but where you're looking to bring your data in as well, using whether it be an on-prem source into CDS via either replication server or logical replication, or a couple of other ways that from the CDS support side of things, we can certainly help to execute against. So in short, the Oracle compatibility, the support from people who have been leading the industry for 14 years as Enterprise DB and 30 years as overall luminaries in the technology itself, and the high availability and ease of use really help to illustrate why it's simple and why we make it quick and efficient to go from an Oracle on-prem solution or an Oracle in a colo, otherwise targeted source into CDS and into the cloud to bring you into the modern state of the Postgres journey. So get started today. There's no credit card required. cds.enterprisedb.com. And as noted, we have regions available across the world. If you have instance types that you're looking for or compute attributes that you don't see available, reach out to us at CDS Help, and we'll do what we can to make your journey a success. So real quick, we may want to touch on some of the questions. Violet, before we do so, how did the poll results turn out?
Yeah, hi, thanks, Jamie and Ajay. For the polls, half of the attendees, 50%, say they have not made a final plan yet, and 35% have got Oracle on-premise, Postgres on-premise, and only 18% Oracle on-premise and Postgres in the crowd.
Okay, thank you. Well, that certainly illustrates that the audience that we've got here today can benefit greatly from everything that we've gone through and demonstrated in the power of EDB and what we bring to your Postgres journey as you're electing to move forward into the cloud platform itself. Do we have any questions?
Um, we do have, but actually we are at the top of the hour, and
Okay.
yep. So I'd like to apologize to the audience for the loss of audio intermittently during the demo and some parts of the webinar. But please be assured that we will be sharing the slides and the recording for this webinar. And definitely, you can write to us for any questions that you have. Thank you for attending. And once again, we really hope that this has been useful to you. More will be organized in the future. So do let us know what you're looking for. So thank you once again, Jamie and Ajay, for taking this for APJ audience. Yeah, wait to hear from us for the slides and the recording. Thank you all.
Thanks, Violet, and thank you, everyone.
Thanks, everyone. Thank you.
Thank you.